Let's look at final exam question number 52, found on page 244 of Everyday Math Demystified, 2nd edition. We're dealing with the hexadecimal number system. That means base 16. In the conventional system called the decimal or base 10 system, we have 10 different single digits, and by 10 we mean that many. However, in base 16 we have 6 more single digits than we have in the base 10 system. Here we have, after 9 comes A, then B, C, D, E, and F, so it goes like this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then instead of 10, 1, 0, we use the symbol A. That represents the decimal number 10. That represents the decimal number 11. That represents the decimal number 12. That represents the decimal 13. That represents the decimal 14. That represents the decimal 15. Now after this, then we get to the decimal number 16, which we would represent as 1, 0. 17 would be 1, 1. 18 would be 1, 2 in base 16. So we can compare these systems side by side in another way. Let's suppose we have 4 digits, X, Y, Z, W, in the base 10 system, a 4-digit numeral. The rightmost digit is the ones place, then to the left of that is the tens place, then to the left of that is the 100s place, and to the left of that the 1000s place, and we keep going up in powers of 10. So this is 10 to the 0th, which equals 1. Any number to the 0th power equals 1. 10 to the 1, except for 0. We don't say anything about 0 to the 0th. That's another story, though. We keep increasing by powers of 10 as we go to the left. But in the hexadecimal number system, we don't use 10, we use 16. So if we have X, Y, let's move that down just a bit. Separate these out. X, Y, Z, W are digits. In the hexadecimal number system, we have the ones place. That's 16 to the 0th power. Then we have the 16s place. That's 16 to the 1. Then we have the 256s place. That's 16 squared. And then 16 cubed. And we keep going on to the left. 16 cubed happens to equal 4,096. So we get a 4,096's place. The question doesn't get anywhere near that involved, though. It just asks us what comes after 99. In other words, what's 99 plus 1? Well, in base 10, of course, it turns out to be 100, 100. But in base 16, this is in base 10, but in base 16, 99 plus 1 equals 9A, which we might call 90A. I don't want to call it 9010. We can call it 90A. That, the digit 9A, here in the question is represented by B.